However, I'm a little behind, only because they're playing with security at Dene College. I hope you're not having the same problems that I'm having. I'm a little bit late anyway because they started QM training, Quality Matters training, so I'm just a little bit behind. This is never going to happen again, I hope. Anyway, well, let's go ahead and get started. This week we're talking about non-experimental research. Last week we talked about experimental research. The real difference between experimental research and non-experimental research is that in experimental research you manipulate the variable. You can manipulate the variable. So it's more of a laboratory. Experimental research is more of a laboratory situation. It's something that they do frequently in science. In the hard sciences, psychology, not so much. In psychology, non-experimental research is makes a lot more sense. And so this week we're going to talk about non-experimental research. Next week we'll talk about surveys. I've told you about my research. It was non-experimental research. I didn't manipulate any of the variables. I didn't, the 5 independent variables that I was dealing with, culture, level of culture, age, gender, level of education, and trauma. I mean, that would have been fairly unethical to try to manipulate any of those. And therefore, since I didn't manipulate anything, it was non-experimental research. So let's go ahead and get into the chapter. Non-experimental research is research that lacks the manipulation of an independent variable. And of course, I didn't do that. This is Amy Schumer. No, that's not Amy Schumer. It's a lady off of SNL, and that's Claire Danes behind her, watching her eat popcorn. Rather than manipulating an independent variable, researchers conducting non-experimental research simply measure variables as they naturally occur in the lab or in the real world. Most researchers in psychology consider the distinction between experimental and non-experimental research to be an extremely important one. This is because although experimental research can provide strong evidence that changes in an independent variable cause differences in a dependent variable, non-experimental research generally cannot. And of course, in psychology, there are very few, if any, absolutes. In science, they're always looking for absolutes. But in psychology, we know that that things change with culture. Things are different with culture, and therefore there are really no absolutes. This inability to make causal conclusions does not mean that non-experimental research is less important than experimental research. Otherwise, we wouldn't have any information about people's psyche. It is simply used in cases where experimental research is not able to be carried out, and that's most of the social sciences. There's just no way that you can do experimental research. Usually it would be unethical. I mean, if I tried to manipulate age, well, that's not going to work. I manipulate education, manipulate gender, manipulate level of I was thinking about this the other day about culture, forcing people to go to a powwow or something. That would have been interesting. Or not letting people go to a powwow. And that still wouldn't have manipulated it. The extraneous variable would have been, something like, well, his grandmother told him about it or something. So that wouldn't work. Experimental research is appropriate when the researcher has a specific research question or hypothesis about a causal relationship between two variables, and it is possible, feasible, and ethical to manipulate the independent variable. It stands to reason, therefore, that the non-experimental research is appropriate, even necessary, when these conditions are not met. Okay, so this is the joke. If you don't control for confounding variables, they'll mask the real effect and mislead you. But if you control for too many variables, your choices will shape the data and you'll mislead yourself. Somewhere in the middle is a sweet spot where you do both, making making you doubly wrong. Stats are a farce and truth is unknowable. See you next week. That's what the researcher was saying, and that's pretty close to being true. Research The research question or hypothesis relates to a single variable rather than a statistical relationship between two variables. How accurate are people's first impressions? Which of these people is going to get the job? Actually, that's the same woman, I think, but that's not her. A guy with a fright wig. Do you think he'll get the job? First impressions. The research question pertains to a non-causal statistical relationship between variables. For example, is there a correlation between verbal intelligence and mathematical intelligence? The research question is about a causal relationship, but the independent variable cannot be manipulated, or participants cannot be randomly assigned to conditions or orders of conditions for practical or ethical reasons. For example, does damage to a person's hippocampus impair the formation of long-term memory traces? And of course, that was not an experiment, but an individual had epilepsy, and they had to take out his hippocampus on one side. And after that, he couldn't form long-term memories. The research question is broad and exploratory, or is about what it is like to have a particular experience. What is it like to be a working mother diagnosed with depression? And that seems to be pretty close. The choice between the experimental and non-experimental approaches is generally dictated by the nature of the research question. The three goals of science are to describe, to predict, and to explain. If the goal is to explain and the research question pertains to causal relationships, then the experimental approach is typically preferred. If the goal is to describe or to predict, a non-experimental approach is to describe or predict, a non-experimental approach is appropriate. So you have to figure out what you're trying to accomplish. I've been teaching this class for, 30 years. When we first started talking about research, we were looking for laws in psychology. We were looking for things that are fairly absolute. But we don't do that anymore. And the reason we don't do that anymore is because we realized that psychology had set itself up to create these human laws, these laws of human behavior. And what we discovered was, especially after World War II, after World War I, things were fairly set in the 19th century. And then at the beginning of the 20th century, everything looked like it was going to follow the same pattern that it had followed back in the 19th century. And then World War I broke out, and all the nations of Europe tried to annihilate each other. And we realized, wait a minute, this is absurd. And that's one of the things that came out of the trenches of World War I was the realization that human behavior is not constantly predictable. That was the arrogance of the 19th century European, was the fact that that behavior is constant, and we can find the laws that dictate how people are going to react. But of course, after the trench warfare of World War I, the mass annihilation of masses of men, we realized that maybe not. So in between the wars, there was a time of looking at the world as as absurd. That was, but not, of course, in psychology. We were trying to keep people from being depressed and dealing with anxiety, and we were trying to figure out psychoses. We were trying to figure out schizophrenia. We were trying to figure out bipolar disorder. At the time, it was called manic depression. We were trying to figure all of these things out, and we were still looking for absolutes. And then World War II happened, and even more of the concept of absolutism was thrown out the window as far as human behavior was concerned. And now, of course, we're not looking for that anymore. Then we got into the 60s and the Vietnam War and the Cold War was taking place. A lot of mind changing was happening. And so one of the things that seems to be happening right now, and part of the conflict in the United States, is the fact that the more conservative individuals are trying to go back to this idea of absolutism. They're trying to go back to an idea that human behavior is predictable, can be controlled, and the other side saying no, that's we've already seen this over and over and over again. There's just no way this can be predictable. But the more conservative idea is that if we just go back to accepting the ideas that we had when these things seem to be true, then we can go back to a world that is more predictable. It looks better to us. And of course, this is the continual argument. And AI doesn't create new ideas. Artificial intelligence doesn't create new ideas. It just recycles all the old ideas that you have, which is fine if you're dealing with a textbook. But if you're looking for an innovative idea, that doesn't exist. It's not going to exist in AI. And the other thing that's going to happen is that the information that they create they're not really creating information. What they're doing is repeating what they've heard, what they've been told, and what they repeat is what they've been told the most. So bad ideas are bad ideas, but it'll be repeated in AI, with AI, because it can't possibly determine which is good and which is bad. Anyway, okay, so I'll get off my philosophical soapbox here, and we'll go on and talk about correlational research. Non-experimental research falls into two broad categories: correlational research and observational research. The most common type of non-experimental research conducted in psychology is correlational research. Correlational research is considered non-experimental because it focuses on the statistical relationship between two variables, but does not include the manipulation of an independent variable. Therefore, since the independent variable wasn't manipulated, it's non-experimental. In correlational research, the researcher measures two variables with little or no attempt to control extraneous variables, and then assesses the relationship between them. And that's correlational research. Non-experimental research falls into the two broad categories. Observational research is non-experimental because it focuses on making observations of behavior in a natural or laboratory setting without manipulating anything. And of course, we can see that people change, things change, everything's changing, everything's constantly evolving. One huge thing for me, of course, I'm 75 years old, but one huge thing for me is the cell phone. Once upon a time, of course, and it wasn't that long ago, and it probably wasn't that long ago for you. We didn't have smartphones. Now we have telephones that are in essence computers, and you can go online anytime and find out just about any information you want. but it wasn't more than 10 or 15 years ago that smartphones really didn't exist. And since smartphones didn't exist, cell phones were just for communication. There wasn't any information on it. You probably had a calculator, but that was it. And then before that, there were no cell phones. Cell phones were, or communication was done by landlines. And now there are hardly any landlines because people don't want them. That people don't need them. They can just buy a cell phone, a smartphone, put it in their pocket, and now they're able to communicate with anybody at any time. As you can see, things do change over time, and things continue to evolve. And of course, eventually it's going to do the same thing. Another thing is, look at the clothes that this guy's wearing. He's got blue jeans on, he's got brown shoes on, he's got a brown coat on, and he's wearing a red tie. In the future, who knows what people are going to be wearing, what kind of things they're going to be looking at. One of the things I noticed today, it's pretty hot today. It's somewhere in the 90s. I can find out exactly how hot it is in Lost Nation, Iowa. Iowa. And the answer is 82 degrees. Is that right? No. Whoops. Wait a minute. Facebook. Leave me alone. It's 82 degrees outside, and it's not that. It's before noon, and it's 82 degrees. Pretty warm. I was talking to my son last night. It was Father's Day yesterday. I was talking to my son last night. He lives in Maryland, and he was saying that it was over 90. And his problem is that he has to walk from. He works anyway. He has to walk a mile in order to get to his office, and it's really hot there. They're under the heat dome. And you're going, we have a heat dome every year. Yeah, you guys do. In Arizona, it's pretty darn hot, and New Mexico. But he's in Maryland, and so when their heat comes with humidity, of course, means sweating. Why am I talking about this? We're talking about observational research and just watching things, watching people, watching human behavior. And of course, I was talking about... I had to take the dog in to the vet this morning, and so I parked the car and took the dog in, and there were people coming and going, and nobody's wearing sleeves. Everybody's sleeveless. So, no t-shirts, no coats, no jackets, no ties, none of that stuff. When psychologists wish to study change over time, they may use various non-experimental approaches. Cross-sectional and longitudinal are used most frequently. Cross-sectional studies involve comparing two or more pre-existing groups of people. What makes this approach non-experimental is that there is no manipulation of an independent variable and no random assignment of participants to groups. The primary limitation of using this design to study the effect of aging is that differences between the groups other than age may account for differences in the dependent variable. In other words, somebody who's 75 will be different than somebody 20 years from now who is 75. So all we can get is a snapshot. But that's a cross-sectional study. We get a look at all of these different people at different ages. A longitudinal study, on the other hand, is where you watch one group of people and they're followed over time as they age, so you get to see how they change. If you look at me right now at 75, and you look at me at your age at 25 or 35 or 45. I probably was not acting the same as you do. Why not? Because, well, for one thing, there were no smartphones and there were no cell phones. Entertainment had to do with watching television. Their computers were there weren't any computers until 1993. The World Wide Web didn't start until 1993. So there are a lot of differences over time. And, all of these new innovations just change things. People that I grew up with, people that are 75, a lot of those individuals had to do something about the war in Vietnam, because the war in Vietnam, that's my cohort group. Uh, some of them went to the military, some of them dodged the draft, a lot of them dodged the draft, most of them dodged the draft. So that's my cohort group. That's something that you guys don't have to worry about, or didn't have to worry about. The fact that because they weren't drafting people, and if you didn't if you weren't able to control your situation, then the next thing you knew, Uncle Sam was telling you that you had to join the military. As much fun as that is. Many observational research studies are more qualitative in nature. In qualitative research, the data are usually non-numerical and therefore cannot be analyzed using statistical techniques. Qualitative data has a separate set of analysis tools depending on the research question. Internal validity is the extent to which the design of a study supports the conclusion that changes in the independent variable caused by any observed differences in the dependent variable. Experimental research tends to be highest in internal validity because the use of manipulation of the independent variable and control of extraneous variables help to rule out alternative explanations for the observed relationship. If the average score on the dependent variable in an experiment differs across conditions, it is quite likely that the independent variable is responsible for that difference. Non-experimental correlational research is lowest in internal validity because these designs fail to use manipulation or control. So weak internal validity for non-experimental, especially correlational research. Correlational research is a type of non-experimental research in which the researcher measures two variables, binary or continuous, and assesses the statistical relationship, in other words, the correlation between them, with little or no effort to control extraneous variables. There are many reasons that researchers interested in statistical relationships between variables would choose to conduct a correlational study rather than an experiment. The first is that they do not believe that the statistical relationship is a causal one, or are not interested in causal relationships. And remember, we're talking about psychology here. We're talking about social science, and in social science, things change so frequently that talking about cause is difficult, is almost impossible. In one person, this type of situation will cause something to happen. In another individual, the very opposite will happen. So looking for causal relationships is a red herring as far as psychology and social sciences is concerned. Another reason that researchers would choose to use a correlational study rather than an experiment is that the statistical relationship of interest is thought to be causal, but the researcher cannot manipulate the independent variable because it is impossible, impractical, or unethical. Some things you can't change, like road rage. Here we go. The question is, as the temperature goes up, does road rage increase? But you can't manipulate that. You can't turn the temperature up outside, and you can't make people angry. Well, I guess you could. You can tell them, imagine that you're on the road. Correlation is, of course, that wouldn't be true either. I mean, it would be a really poor experiment. Correlation is also used to establish the reliability and validity of measures. Another strength of correlational research is that it is often higher in external validity than experimental research, which is logical because in this case we're seeing people in their natural environment. We're not manipulating the environment. In an experiment, of course, you're manipulating the environment, and you're trying to control variables. As greater controls are added to experiments, internal validity is increased, but often at the expense of external validity, as artificial conditions are introduced that do not exist in reality. Correlational studies typically have low internal validity because nothing is manipulated or controlled, but they often have high external validity. Since nothing is manipulated or controlled by the experimenter, the results are more likely to reflect relationships that exist in the real world. The defining feature of correlational research is that the two variables are measured, neither one is manipulated, and this is true regardless of whether the variables are quantitative or categorical. It does not matter how or where the variables are measured. Correlations between quantitative variables are often presented using scatter plots. These are scatter plots. In a positive relationship, higher scores on one variable tend to be associated with higher scores on the other. In other words, they move in the same direction, either both up or both down. A negative relationship is one in which the higher scores on one variable tend to be associated with lower scores on the other. In other words, they move in opposite directions. And this is a scatter plot for a positive relationship, and this is a scatter plot for a negative relationship. As one increases, the other decreases. And this one, as one increases, the other one increases as well. That's a positive one. And if there's no line in your scatter plot, then there is no relationship between the two. See, this is a high this score, but it's a low this score. This is a low this score, but it's a high this score. Oh, wait a minute, it's a low this score, it's a high this score. Anyway, the strength of a correlation between quantitative variables is typically measured using a statistic called Pearson's correlation coefficient, or Pearson's R. Pearson's R ranges from minus 1.00, the strongest possible negative relationship, to a plus 100, the strongest possible positive relationship. A value of 0 means that there is no relationship between the variables. When Pearson's R is 0, the points on a scatter plot form a shapeless cloud like this, or this, or this. As its value moves toward negative 1.00 or positive 1.00, the points come closer and closer to falling on a single straight line. And this is a positive relationship, and this is a negative relationship. Correlation coefficients near plus or minus 1.0 are considered small. Values near plus or minus 0.30 are considered medium, and the values near plus or minus 0.50 are considered large. And of course, this is a really high one, and this is a really high one. That one's not too bad. That's probably in the 50% range. But this is just all over the map. There are two reasons that correlation does not imply causation. The first is called the directionality problem. Two variables, x and y, can be statistically related because x causes y or because y causes x. The second reason that correlation does not imply causation is called the third variable problem. Two variables, x and y, can be statistically related not because x causes y or because y causes x, but because some third variable, z, causes both x and y. And of course, this is the joke. They stop turning on the seatbelt sign. It makes the plane fly bumpy. So he's seeing the wrong correlation there. And of course, we're talking about the x-axis and the y-axis. That has to do with statistics. The most complex correlational research involves measuring several variables and then assessing the statistical relationships among them. This approach is often used to assess the validity of new psychological measures. When researchers study relationships among a large number of conceptually similar variables, they often use a complex statistical technique called factor analysis. Sorry, I needed a drink. In essence, factor analysis organizes the variables into a smaller number of clusters such that they are strongly correlated within each cluster but weakly correlated between clusters. Each cluster is then interpreted as multiple measures of the same underlying construct. These underlying constructs are also called factors, as confusing as that is. Factors are not categories. Factors are constructs that operate independently of each other. Factor analysis reveals only the underlying structure of the variables. It is up to researchers to interpret and label the factors and to explain the origin of that particular factor structure. And this is economic success. Socioeconomic status is determined by your education, your family situation, and your income. If we put all these together, we get socioeconomic status. Just because you have a PhD doesn't mean that you're going to be, well, you're not going to have enough money to be this guy. That's for sure. Not if you're in education. Family situations. Sometimes you inherit lots and lots and lots and lots of money. That's what happened with former President Trump. His family situation was really good because his father, he inherited lots of money from his father, and then he seemed to have stolen it from his other relatives. Anyway, and that's what made him a wealthy man. And of course, he had all that money, and that's what made him a wealthy man as well. So there you go. And these are all factors. These are all factors that lead to the concept of socioeconomic status. An important use of complex correlational research is to explore possible causal relationships among variables. It is true that correlational research cannot unambiguously establish that one variable causes another. Complex correlational research, however, can often be used to rule out other plausible interpretations. The primary way of doing this is through the statistical control of a potential third variable. Instead of controlling these variables through random assignment or by holding them constant, as in an experiment, the researcher instead measures them and includes them in the statistical analysis called partial correlation. Using this technique, researchers can examine the relationship between two variables, while statistically controlling for one or more potential third variables. What happened in my research, when I was putting it all together, I had several friends that were advising me, and one of them said, well, if you really want to understand what causes resilience, then one thing that you need to study is was just thinking of this, and it just fled my mind. Spirituality. I think I told you this before. I didn't want to get into spirituality because spirituality included being a traditional American Indian. It also included the Catholicism, which was massive on the reservation. And then there was this undercurrent of evangelicals on the reservation that were causing all kinds of interesting problems. So we had all these three aspects of spirituality. And of course, it would be very difficult to separate one from the other. Traditionalism, Catholicism, and then this evangelicalism that was wandering around the reservation. And I really didn't want them to. I wanted them to think of themselves as American Indian, not as a Catholic or a traditional or an evangelical. So I left it out. It was a third variable. Was it there? Probably, but I just ignored it. But it was a potential third variable that could have caused interesting problems. The individual that suggested that I look for traditionalism, I'm sorry, for spirituality, was thinking of spiritual traditionalism. And I figured that I picked up that concept in level of culture, adherence to culture. Once a relationship between two variables has been established, researchers can use that information to make predictions about the value of one variable given the value of another variable. For instance, once we have established that there is a correlation between IQ and grade point average, we can use people's IQ scores to predict their grade point average. Thus, while correlation coefficients can be used to describe the strength and direction of relationships between variables, regression is a statistical technique that allows researchers to predict one variable given another. Regression can also be used to describe more complex relationships between more than two variables. Typically, the variable that is used to make the prediction is referred to as the predictor variable. And of course, I use regression analysis in my research, in my dissertation. The regression equation has the following general form. Y equals B1 times X1. Y in this formula represents the person's predicted score on the outcome variable B1. Variable B1 represents the slope of the line depicting the relationship between the two variables, or the regression weight. And X1 represents a person's score on it, the predictor variable. You can see that to predict a person's score on the outcome variable, y, one simply needs to multiply their score on the predictor variable, x, by the regression weight. And this is what we are looking for. So they want you to kind of assume that you can figure it out before you actually do the research. This is what happened to me. They wanted me to predict what I would see. And I found that illogical. I didn't like that idea. While simple regression involves using one variable to predict another, multiple regression involves measuring several variables, x1, x2, x3, all the way to xi, and using them to predict some outcome variable, or y. And that's what I was doing. I was putting all of these different independent variables together, and I was trying to predict resilience. So mine was a multiple regression. Multiple regression can also be used to simply describe the relationship between a single variable outcome variable and a set of predictor variables. And this is the kind of stuff that I came up with because they were all over the map. Age, gender, education. And my assumption was that education would have a huge amount to do with resilience, but I was completely wrong. Other people had predicted that women, females, young ladies, are more resilient than young men. And that was wrong. What else? Age. Older people, theoretically, and the person that did the first resilience work was dealing with people in a nursing home. And so her survey actually skewed toward people that were older. But in this case, age didn't have anything to do with it. And of course, the true predictor was the level of culture that people adhered to. The result of a multiple regression analysis is R. That doesn't make any sense. Equation that expresses the outcome variable as an additive combination of predictor variables. I'm going to do this, and then I'm going to do this, and okay. All right. All right. The regression equation has the following general form. Y equals b1 x1 plus b2 x2 plus b3 x3 plus, regression weights b1, b2, and so on indicate how large a contribution a predictor variable makes on average to the prediction of the outcome variable. Specifically, they indicate how much the outcome variable changes for each 1 unit change in the predictor variable. And this is looking at BMI and calorie intake. The more calories you take in, the higher your BMI, which is very logical. So that's what I was looking for with all of my factors, and that's not what I found. I found that all my factors, my factors didn't have anything to do with age, gender, education. Didn't have anything to do with resilience. It had to do with level of culture, and the trauma was backwards. It was a negative relationship. So normally, the more trauma you've been through, or not normally, but this is what they had seen before, the more trauma you'd been through, the less resilient you were. But in the population that I was testing, it was actually the other way around. So the more trauma you'd been through, the more resilient you were. Well, that didn't make any sense. It was supposed to be a negative reaction, but it was not. So actually, that wasn't right. Wait a minute. I said it wrong. I said it wrong. I'm sorry. Wait a minute. Okay. So what it was supposed to be a negative correlation. The higher the trauma, the lower the resilience. So there was supposed to be a correlation between the two, but there was no correlation at all. So even people with a lot of trauma, they could have high resilience or low resilience, but it was not a factor. And that was the only population. The American Indian population was the only population that we saw this in, and it wasn't just my research. It was also research from the Navajo Nation. It was also research from the Hopi Reservation. It was also research that was done in Oklahoma within American Indian population. The trauma was not a factor in resilience. There, I said it right. The advantage of multiple regression is that it can show whether a predictor variable makes a contribution to an outcome variable over and above the contributions made by other predictor variables, i.e. it can be used to show whether a predictor variable is related to an outcome variable after statistically controlling for other predictor variables. This is really kind of interesting study. What was it? Oh, as your age goes, this is red is women and blue is men. And as your age goes up, your blood pressure tends to go up. But it's less so for women than it is for men. And the car had to do with road rage, if I remember correctly, and heat. That's why this picture is here. The textbook is primarily about quantitative research, in part because most studies conducted in psychology are quantitative in nature. Quantitative researchers typically start with a focused research question or hypothesis. They collect a small amount of numerical data from a large number of individuals. They describe the resulting data using statistical techniques. and draw general conclusions about some large population. There is an important alternative to quantitative research called qualitative research. Qualitative research originated in the disciplines of anthropology and sociology, but is now used to study psychological topics as well. Qualitative researchers generally begin with a less focused research question, collect large amounts of relatively unfiltered data from a relatively small number of individuals, and describe their data using non-statistical techniques such as grounded theory, thematic analysis, critical discourse analysis, or interpretive phenomenological analysis. They are usually less concerned with drawing general conclusions about human behavior than with understanding in detail the experience of their research participants. Now, this is really kind of interesting because when I was doing my research on the Fort Belknap Reservation, I wanted to do quantitative research, as you have seen, or as I have described. I was talking about age, gender, education. I had an instrument for the resilience. I had an instrument for trauma, and I had an instrument for cultural awareness or adherence to culture. So everything was quantitative. Each aspect was quantitative, whether it was numerical or whether it was categorical. It was quantitative. At the same time, and one of the problems I had was the fact that one of the administrators from the school had just come back from the University of Arizona. She just finished her master's degree. And at that time, this was in the early, when was this? In the early 2000s, the University of Arizona, the American Indian Studies Department anyway, was saying that you couldn't do quantitative research on American Indians. You could only do qualitative research. And they had beaten this into her mind that it was impossible to do, or it wasn't accurate to do quantitative research. And when she came back, she was adamant that I shouldn't be able to do my research because you can't do quantitative research on American Indians. That's what she said. And so if she'd gone to the University of Oklahoma, University of Nebraska, ASU, if she'd gone any place except the Arizona University, then it wouldn't have been such a huge argument. But because that was her mindset, I had a difficult time getting my research approved. As a matter of fact, I never did get approved on the reservation because of what she kept telling people. Qualitative research. I would have done qualitative research, but it didn't. It seemed to me that I was trying to correct a mistaken mindset. A lot of people, especially, and it was really kind of interesting because my wife was working at a clinic, and an individual came and talked to an individual from Washington D.C. came and talked about nicotine addiction, and he was the one that, and at one point he said that American Indians have an addiction problem, especially with nicotine and with alcohol. And I said, well, what kind of statistics do you have? And he said, well, everybody knows. Everybody knows. It was one of those everybody knows situations. But at that time, there were statistics out that showed that the European population in Montana had a much stronger addiction rate than American Indians in that area. It's really kind of interesting. And we told him that, and he, everybody knows, it's one of those everybody knows situations. And so what I was trying to do, I was trying to correct this misperception that American Indians have this problem with addiction. That, it seems that they were saying that it's congenital, that, that this is a natural thing, that there's nothing you can do about it. But I was trying to say that it wasn't true. Anyway, really kind of interesting situation. So I thought that doing quantitative research would be a stronger argument than qualitative research. You know, just interview half a dozen people or whatever. The relative weaknesses of quantitative research are the relative strengths of qualitative research. Qualitative research can help researchers to generate new and interesting research questions and hypotheses. Qualitative research can provide rich and detailed descriptions of human behavior in the real-world context in which it occurs. Similarly, qualitative research can convey a sense of what is actually like to be a member of a particular group or in a particular situation. What qualitative researchers often refer to as the lived experience of the research participants. Data collection approaches in qualitative research are quite varied and can involve naturalistic observation, participant observation, archival data, artwork, and many other things. But one of the most common approaches, especially for psychological research, is to conduct interviews. Interviews in qualitative research can be unstructured, consisting of a small number of general questions or prompts that allow participants to talk about what it is of interest to them, or structured, where there is a strict script that the interviewer does not deviate from. Most interviews are in between the two and are called semi-structured interviews, where the researcher has a few consistent questions and can follow up by asking more detailed questions about the topics that they come up with. Such interviews can be lengthy and detailed, but they are usually conducted with a relatively small sample. Another approach used in qualitative research involves small groups or of people who participate together in interviews focused on a particular topic or issue, and this is known as a focus group. The interaction among the participants in a focus group can sometimes bring out more information than can be learned in a one-on-one interview. The use of focus groups has become a standard technique in business and industry among those who want to understand consumer tastes and preferences. The content of all focus group interviews is usually recorded and transcribed to facilitate later analysis. However, we know from social psychology that group dynamics are often at play in any group, including focus groups, and it is useful to be aware of those possibilities. Group dynamics. Who's the loudmouth? Quantitative and qualitative research generally differ along several important dimensions, but it is the method of data analysis that distinguishes them more clearly than anything else. In qualitative research, there are many ways to analyze data. Grounded theory was developed within the field of sociology in the 1960s and has gradually gained popularity in psychology. It is typical for the researcher to start with a theory, derive a hypothesis from that theory, and then collect data to test that specific hypothesis. In qualitative research, using grounded theory, researchers start with the data and develop a theory or an interpretation that is grounded in those data. They do this analysis in stages. First, they identify ideas that are repeated throughout the data. Then they organize these ideas in a small number of broader themes. Finally, they write a theoretical narrative, an interpretation of the data in terms of the themes that they have identified. Given their differences, it may come as no surprise that quantitative and qualitative research in psychology and related fields do not coexist in complete harmony. Some quantitative researchers criticize qualitative methods on the grounds that they lack objectivity, are difficult to evaluate in terms of reliability and validity, and do not allow generalization to people or situations other than those actually studied. At the same time, some qualitative researchers criticize quantitative methods on the grounds that they overlook the richness of human behavior and experience and instead answer simple questions about easily quantifiable variables. And of course, both of them are correct. And this is why I keep saying that if you put two psychologists in a room, you're going to get an argument. They very rarely will agree on everything, and the quantitative and qualitative thing is really strong. Cognitive psychologists, for example, are quantitative psychologists, and whether they actually believe in qualitative research or not, I'm not really sure. But they will argue your leg off, trying to get you to quantify everything in your research. Seems like everywhere I go, I run into cognitive psychologists. Just one, though. And they're always teaching research methods and statistics. Qualitative researchers are well aware of the issues of objectivity, reliability, validity, and generalizability. They have developed a number of frameworks for addressing these issues, which are beyond the scope of our discussion. Quantitative researchers are well aware of the issue of oversimplification. They do not believe that all human behavior and experience can be adequately described in terms of a small number of variables and the statistical relationships among them. A lot of times the statistics they use are kind of questionable. You're quantifying something that is unquantifiable. A good example would be depression. You're going to quantify how depressed I am. Wait a minute, let me think about this for a second. So you gave me a test, and you asked me to quantify things. On a scale of 1 to 5, how depressed am I? Wait a minute. Okay, if I'm a positive person, anyway, you're not going to get the same results, and it's fairly subjective. They use simplification as a strategy for uncovering general principles of human behavior. Many researchers from both the quantitative and qualitative camps now agree that the two approaches can be and should be combined into what has come to be called mixed methods research. One approach to combining quantitative and qualitative research is to use qualitative research for hypothesis generation and quantitative research for hypothesis testing. A second approach to combining quantitative and qualitative research is referred to as triangulation. The idea is to use both quantitative and qualitative methods simultaneously to study the same general questions and to compare the results. If the results of the quantitative and qualitative methods converge on the same general conclusion, they reinforce and enrich each other. If the results diverge, then they suggest an interesting new question. Why do the results diverge, and how can they be reconciled? The term observational research is used to refer to several different types of non-experimental studies in which behavior is systematically observed and recorded. The goal of observational research is to describe a variable or set of variables. The goal is to obtain a snapshot of specific characteristics of an individual, group, or setting. Observational research is non-experimental because nothing is manipulated or controlled, and as such we cannot arrive at causal conclusions using this approach. The data that are collected in observational research studies are often qualitative in nature, but they may also be quantitative or both, mixed methods. Naturalistic observation is an observational method that involves observing people's behavior in an environment in which it typically occurs. And naturalistic observation started with Jane Goodall watching chimpanzees in Africa. But of course, anybody can observe anything. Where was I that I was doing observing people? Now I can't remember where I was. Oh, great. One time I did naturalistic observation. I was observing people going into a prom. couples going into a prom. And the theory was that the dominant side is the right side, because if a male's walking on the right, then he's holding the girl's right hand with his left hand, and he's got his right hand free to defend her. That was the idea. So I did naturalistic observation, watching people walk. There was a guy at Purdue University that was watching couples, and he just looked out his window and he wrote down how many males were on the left or the right side and how many females were on the right side in the couple the dyad the coupling dyad, and it was about 70%. Males on the right side. Of course, about 10% of the population is left-handed, so their dominant side would be to walk on the left side if you're left-handed, the males anyway. Naturalistic observation is a type of field research as opposed to a type of laboratory research. Researchers engaged in naturalistic observation usually make their observations as unobtrusively as possible so that participants are not aware that they are being studied. Such an approach is called disguised naturalistic observation, and that's what I was doing. I was just sitting in my car watching people go by and writing down which side the male was on, whether he was on the right or the left. Now, they had to be holding hands, or they had to be touching each other. If the two of them were not touching each other, I didn't count them because I figured they weren't really a couple. Anyway, it was disguised naturalistic observation. Researchers can conduct undisguised naturalistic observation where the participants are made aware of the researcher presence and monitoring of their behavior. However, one concern with undisguised naturalistic observation, this is where they know they're being watched, is something called reactivity. Excuse me. Reactivity refers to when a measure changes participants' behavior. In the case of undisguised naturalistic observation, if I had stood there and I said, okay, I'm going to watch you guys walk into the prom, if you're touching each other, then I'm going to watch to see which side people are standing on. Okay, go ahead, everybody walk in. Then probably I would get people going, what am I supposed to do? What am I supposed to do? And that would be reactivity. In the case of undisguised naturalistic observation, the concern with reactivity is that when people know that they're being observed and studied, they may act differently than they normally would. And this type of reactivity is known as the Hawthorne effect. And the reason it's known as the Hawthorne effect is because they were doing time studies at the Hawthorne plant outside of Chicago. The Hawthorne plant made Bell Telephone telephones. That's what they did. And they were trying to increase the productivity. And no matter what they did, the observers came in, and no matter what they did, they found that it increased productivity. So just by them being there, they were producing more productivity. Now the funny thing was, when they had them switch back to the old way of doing things, it increased productivity again. So what was going on? It was reactivity. They were reacting to the fact that they were being watched, and that's why it's called the Hawthorne effect, because of the Hawthorne plant in right outside of Chicago. Another form of observational research is participant observation. In participant observation, researchers become active participants in the group or situation they are studying. Participant observation is very similar to naturalistic observation in that it involves observing people's behavior in the environment in which it typically occurs. As with naturalistic observation, the data that are collected can include interviews, usually unstructured, notes based on their observations and interactions, documents, photographs, and other artifacts. The only difference between naturalistic observation and participant observation is that researchers engaged in participant observation become active members of the group or situations that they are studying. The basic rationale for participant observation is that there may be important information that is only accessible to or can be interpreted only by someone who is an active participant in the group or situation. Like naturalistic observation, participant observation can be either disguised or undisguised. In disguised participant observation, the researchers pretend to be members of the social group that they are observing and conceal their true identity as researchers. And this is something that Festinger did. There was a doomsday cult in New York City, and he joined the group in order to watch their behavior and find out what their mindset was. And of course, since it was a doomsday group, there was an end point when the world was supposed to end, and of course, it didn't happen. Obviously, it didn't happen because we're still here. The same thing happened kind of with Leah Remini, with the Scientologists. She was a part of that group, and actually, she was born into the group, I think. Anyway, now she's reporting on it. That's kind of participant observation, is the fact that you're part of the group. So if I was a Hell's Angel, and then afterwards I started talking about what it's like to be a Hell's Angel, then that would be participant observation. Probably be disguised. Well, I'm not big enough to be a Hell's Angel, for one thing. And I'd never ridden a motorcycle, so that wouldn't work. What if I became a Navajo? What if I learned Navajo and became a Navajo and was adopted into the tribe? That would be participant observation. But of course, I couldn't do that because in order to be Navajo, you need to be able to speak the language. I'd have to learn the language. And then you'd have to be able to interpret it properly in order to understand the culture. And already having white culture embedded in my psyche, I'm not exactly sure I could do that at this point. Well, I'm 75, so it's not going to happen anyway. It would never happen anyway. And that's one of the reasons why I don't think that it's, with me trying to interpret your language, and with your language being part of your religious structure, I think it would be too possible for me to misinterpret your spirituality, and that's why I don't do it. So there you go. You'd have me arguing that this word doesn't mean that. That wouldn't be right. Anyway, I don't think it would be. That would be appropriation, misappropriation. One of the primary benefits of participant observation is that the researchers are in a much better position to understand the viewpoint and experiences of the people that they are studying when they are a part of a social group. And this has to do with cults and whatnot. The primary limitation with this approach is that the mere presence of the observer could affect the behavior of the people being observed. While this is also a concern with naturalistic observation, additional concerns arise when researchers become active members of the social group that they're studying, because they may change the social dynamic and or influence the behavior of the people that they are studying. Similarly, if the researcher acts as a participant observer, there can be concerns with biases resulting from developing relationships with the participants. The researcher may become less objective, resulting in more experimenter bias. And of course, the bias is the problem. So if I joined an organization like Heaven's Gate, you remember those are the guys that thought that they were going to join aliens, extraterrestrials, on a spaceship. And then when the Hale-Bopp comet came by, they decided that there was a spaceship behind it, and they were going to join them. And the only way for them to join them was to rid themselves of their earthly body and only become a spiritual body so that they could join the aliens up on their spaceship. So they all committed suicide. Now, if I had joined Heaven's Gate just to find out what the hell was going on with these people, then that would have been participant observation. If I had, or if I had just gone into the group and watched, that would be participant observation. So, if I joined the group, I would have had to have committed suicide. An observational method is structured observation. Here, the investigator makes careful observations of one or more specific behaviors in a particular setting that is more structured than the settings used in naturalistic or participant observation. Often the setting in which the observations are made is not the natural setting. Instead, the researcher may observe people in the laboratory environment. Alternatively, the researcher may observe people in a natural setting, like a classroom setting, that they have structured some way. Or, for instance, that by introducing some specific task participants are to engage in, or by introducing a specific social situation or manipulation. Structured observation is very similar to naturalistic observation and participant observation in that in all three cases, researchers are observing naturally occurring behavior. However, the emphasis in structured observation is on gathering quantitative rather than qualitative data. Researchers using this approach are interested in a limited set of behaviors. This allows them to quantify the behaviors that they are observing. Structured observation is less global than naturalistic or participant observation because the researcher engaged in the structured observations is interested in a small number of specific behaviors. Rather than recording everything that happens, the researcher only focuses on very specific behaviors of interest, like if they were looking for violence in a classroom setting or anger in a classroom setting. They wouldn't annotate anything that didn't have to do with anger or violence. They wouldn't write down all the happy stuff that happened. When the observations require judgment on the part of the observers, a process referred to as coding is typically required. Coding generally requires clearly defining a set of target variable behaviors. The observers then categorize participants individually in terms of which behavior they've engaged in, a number of times they engaged in each behavior. Observers might even record the duration of each behavior. The target behaviors must be defined in such a way that guides different observers to code them in the same way. This difficulty with coding illustrates the issue of inter-rater reliability. Are they, they're watching the same interview and they're looking for specific words. Are they interpreting what the person says the same? Researchers are expected to demonstrate the inter-rater reliability of their coding procedure by having multiple raters code the same behaviors independently and then showing that the different observers are in close agreement. And of course, this doesn't have anything to do with that type of coding. This has to do with writing computer code. But perfect code, that's what we're looking for. Perfect coding. A case study is an in-depth examination of an individual. Sometimes case studies are also completed on social units, for example, a cult, and events, for example, a natural disaster. Most commonly in psychology, case studies provide a detailed description and analysis of an individual. Often the individual has a rare or unusual condition or disorder or has damage to a specific region of the brain. Like many observational research methods, case studies tend to be more qualitative in nature. Case study methods involve an in-depth and often a longitudinal examination of an individual. Depending on the focus of the case study, individuals may or may not be observed in their natural setting. If the natural setting is not what is of interest, then the individual may be brought into a therapist's office of a researcher's lab for study. The bulk of the case study report will focus on in-depth descriptions of the person rather than on statistical analysis. Case studies case studies are useful because they provide a level of detailed analysis not found in many other research methods, and greater insights may be gained from this more detailed analysis. And of course, case studies is what Freud used. He had some very famous case studies. I'm not exactly sure there was any other type of research at that time. Certainly not social science research. And this is one of the complaints about Freud. Now, how can you even say that Freud knew what he was doing? There's no research that supports that. The cognitivists really hate Freud because there's no research to support what he did. Well, no, there wasn't any research back then. There was scientific research, but there was no psychological research. Not important. I've had this argument many, many times. I'm just letting you guys get in on it. As a result of the case study, the researcher may gain a sharpened understanding of what might become important to look at more extensively in future, more controlled research. Case studies are also often the only way to study rare conditions because it may be impossible to find a large enough sample of individuals with the condition to use quantitative methods. Although at first glance a case study of a rare individual might seem to tell us little about ourselves, they often do provide insights into normal behavior. Another approach that is often considered observational research involves analyzing archival data that have already been collected for some other purpose. As with naturalistic observation, measurement can be more or less straightforward when working with archival data. Content analysis is a family of systematic approaches to measurement using complex archival data. And that is the end of the chapter. If you are listening to this, it means that I have been able to get on Canvas. I tried this morning, and they wouldn't let me on for no reason whatsoever. They're working with security, but when you get if you're listening to this, then obviously you've been able to get on, and I've been able to get on at that point. But getting all this stuff online right now is not nigh on to impossible because I can't get logged on. So if you're hearing this, it means that I did. I'll talk to you guys next week.